once again to UKC Maths. In this lecture, I am going to explain the argument of a complex number and their various properties and working rule to find the principal argument of a complex number. Let us first see what is argument of a complex number. First, be clear that the argument of a complex number and amplitude of a complex number both are same thing. Both are synonymous. Let z equal to a plus ib be a complex number. Then the argument of this complex number z is denoted by argz or ampz. Say the argument of this complex number is theta, then it is defined as theta equal to tan inverse b by a, where b is the imaginary part of the complex number and a is the real part of the complex number. You can also write in terms of rez and imz as theta equal to tan inverse imz by rez, where a is rez and b is imz. One thing to be noted that argument of complex number z equal to 0 is not defined. Now let us understand the argument of a complex number through a small illustration. Suppose z equal to 1 plus I be a complex number. Then according to definition, the argument of z is equal to tan inverse 1 by 1, which is equal to 45 degrees. So 45 degrees is the argument for this complex number. The most important thing which has to be taken care is that the argument of a complex number is not unique. It is a multi-valued function. It can take a numerous values. Suppose if theta be one of the argument of a complex number z, then the argument of the complex number z is given by argz equal to theta plus 2k pi, where k is an integer. We can visualize this concept of argument through this small diagram. You can see that the complex number z equal to a plus ib is represented by the ordered pair a comma b in the complex plane, and theta represents one argument of this complex number. So theta plus 2 pi is also an argument of this complex number. Similarly, if you take two loop of 2 pi in anti-clockwise direction, you will have theta plus 4 pi is the argument of this complex number. And the same way, if you take n loops in anti-clockwise direction, you will find theta plus 2 and pi is also an argument of this complex number. Similarly, if you traverse in clockwise direction by 2 pi, you will get theta minus 2 pi, which is an argument of this complex number, because when angle are traversed in clockwise direction, it is treated as negative. When it is traversed in anti-clockwise direction, it is treated as positive. If you take two loop of 2 pi in clockwise direction, you will have theta minus 4 pi, which represents the argument of same complex number z equal to a plus ib. If you take 3 loop of 2 pi in clockwise direction, you will find theta minus 6 pi is the argument of the same complex number z. In the same way, if you take n loops in the clockwise direction, you will find theta minus 2n pi is an argument of this complex number. So in general, you can write argument of z equal to theta plus 2k pi, where k is an integer. Since k is an integer, so it can take care of both positive and negative values. Now let us see what is principal argument. We have just seen that the argument of a complex number z is given by argz equal to theta plus 2k pi, where k is an integer. In this way, we can visualize that this argument of z is a multi-valued function. It can take a numerous values according to different values of k. Now, principal argument is a name that is given to the argument which originally lie between 0 to 2 pi. Now there are two ways to traverse this argument of 0 to 2 pi. First is in one loop from 0 to 2 pi in anti-clockwise direction, and second is the upper half of the real axis in anti-clockwise direction and traverse lower half of the real axis in clockwise direction. You already know that when an angle is traversed in clockwise direction, it is treated as negative and all. So there are two set of conventions by which the principal argument of a complex number is evaluated. In the first convention, the value of the argument is allowed to vary between 0 to 2 pi, excluding the value of 2 pi, means in the semi-open, semi-closed interval 0 to 2 pi, excluding value 2 pi. And in the second convention, the argument of the complex number is allowed to vary between minus pi to pi, excluding the value of minus pi, means semi-open, semi-closed interval which is open at left minus pi to pi. These both conventions gives the value of argument which lies originally between this 0 and 2 pi loop. So this convention one is older one, it was used from long time and all. But nowadays this second convention is widely used in many textbooks to find the value of principal argument. And here the value of argument is allowed to vary between minus pi to pi, excluding the value of minus pi. We usually take principal values of argument in our mathematical discussions if nothing is specifically given about the argument. Now we will see the working rule to find the principal argument of a complex number z equal to a plus ib. First we will see the working rule to find the principal argument of a complex number z equal to a plus ib, in which the value of argument is allowed to vary between 0 to 2 pi, excluding the value of 2 pi. So concentrate on these steps. If z equal to a plus ib be a given complex number. Step 1, put a equal to r cos theta and b equal to r sin theta. Step 2, from the two values of step 1, you find theta equal to tan inverse absolute value of b by a. You only take absolute value. Step 3, since theta is a multi-valued function, so choose the value of theta which satisfy this inequality that theta is greater than equal to 0 and less than equal to 90. Or theta is greater than equal to 0 and less than equal to pi by 2. And in step 4, now based on the quadrant in which the complex number z equal to a plus ib lies, I think you must have some geometrical knowledge how a complex number is represented in the complex plane. For simplicity, I have represented 4 complex number z1, z2, z3, z4 in 4 quadrants and all according to their coordinates. So based on the signs of real and imaginary part, you can decide in which quadrant a complex number lies. And then principal argument of the complex number is evaluated according to this following table. Suppose both real and imaginary part, both a and b are positive. Then according to this convention, the principal argument of the complex number z will be given simply as theta, what we have just obtained. If your complex number lies in the second quadrant, that is, the real part a is negative and imaginary part b is positive, then the principal argument is given as pi minus theta or 180 degree minus theta. Suppose your complex number lies in the third quadrant, so here the real part will be negative and imaginary part b will also be negative. Here the principal argument of the complex number will be given as pi plus theta or 180 degree plus theta. And suppose your complex number lies in the fourth quadrant. So in the fourth quadrant, what is the characteristic? The real part will be positive and imaginary part will be negative. The principal argument of the complex number z will be given by 2 pi minus theta or 360 degree minus theta. So if you follow these algorithms and you remember this table, you will find the argument of a complex number very easily. Now let us understand the concept of the argument through this convention one by a small illustrations. Suppose you are given a complex number z equal to 1 minus I and you are told to find the principal argument of this complex number. Then according to algorithms what we have just studied, put 1 equal to r cos theta and minus 1 equal to r sin theta and follow the algorithms what I have told. You will find theta equal to 45 degree. By the little knowledge of geometry, you can clearly visualize that this complex number 1 minus I lies in the fourth quadrant. And according to our table what we have given, if a complex number lies in the fourth quadrant, then the principal argument is given by 2 pi minus theta. So here theta is 45 degree. So the principal argument of this complex number z is equal to 360 degree minus 45 degree, which is equal to 315 degree. So 315 degree is the value of the principal argument for the complex number z equal to 1 minus I. Now let us take another complex number. Take z equal to minus 1 minus under root 3. According to algorithm what we have studied, put minus 1 equal to r cos theta and minus under root 3 equal to r sin theta, and follow the steps. You will find theta equal to 60 degrees. With the knowledge of geometry, you know that this complex number z equal to minus 1 minus root 3i lies in the third quadrant. And according to the table what we have given, if a complex number lies in the third quadrant, then its principal argument is given by pi plus theta or 180 degree plus theta. So here theta is 60 degree. So 180 degree plus 60 degree equal to 240 degree is the value of the principal argument of this complex number z equal to minus 1 minus root 3i. Now let us see the working rule to find the principal argument of the complex number z equal to a plus ib through the second convention, means in which the value of argument is allowed to vary between minus pi to pi, excluding the value of minus pi. The algorithm is almost same as we have studied in the convention 1. Here also put a equal to r cos theta and b equal to r sin theta. In step 2, find the value of theta equal to tan inverse absolute value of b by a. And since theta is a multi-valued function over here, so choose the value of theta which satisfy the inequality, as theta is greater than equal to 0 less than equal to pi by 2, or theta is greater than equal to 0 less than equal to 90 degree. And in step 4, now based on the quadrant in which our complex number lies, means based on the signs of real and imaginary part a and b, the value of the principal argument is given by this following table. For basic understanding, I have taken 4 complex numbers z1, z2, z3, z4 lying in all the 4 quadrants respectively. Now let us see if your complex number lies in the first quadrant, that is the real part of the complex number is positive and imaginary part of the complex number is also positive, then the value of the principal argument is given by theta obtained from the step 3. If your complex number z equal to a plus ib lies in the second quadrant, then in this case the real part a would be negative and the imaginary part b will be positive. Here the principal argument will be given by pi minus theta or 180 degree minus theta. Suppose your complex number lies in the third quadrant, means real part is also negative and imaginary part is also negative, means both a and b are negative. So in this case the principal argument is given by minus pi plus theta or minus 180 degree plus theta. And suppose your complex number lies in the fourth quadrant, that is the real part is positive and imaginary part is negative. So in this case the principal argument is simply given by minus of theta, where theta is as obtained by step 3. If you have some basic knowledge of geometry, that is how complex numbers are represented in different quadrants based on the signs of real and imaginary part, and if you memorize this table, you can easily find the value of principal argument of the complex number. So let us understand this concept of argument found from this convention through small illustrations and all. We have taken the same 2 examples what we have taken in convention 1 to find the principal argument. Here also suppose z equal to 1 minus I be the complex number and you have to find the principal argument. According to algorithm, you put 1 equal to r cos theta and minus 1 equal to r sin theta, and in this way you will get theta equal to 45 degree. Now it is clear that this complex number 1 minus I lies in the fourth quadrant, and according to our formula given in the table, the value of principal argument for this complex number will be minus theta, so it will be minus 45 degree. Let us take second example, z equal to minus 1 minus root 3i, and suppose we have to find the value of principal argument of this complex number according to this convention. So we will follow the same algorithm. We will put minus 1 equal to r cos theta and minus under root 3 equal to r sin theta, and follow the steps as given in the algorithm, and we will finally find that theta equal to 60 degree. Now it is clear that this complex number lies in the third quadrant. Now according to the formula given in the table, If a complex number lies in the third quadrant, its principal argument is given by the formula minus pi plus theta or minus 180 degree plus theta, which comes out to be minus 120 degree. Now let us have a comparative study of the principal argument obtained through these two conventions. We have taken the same two examples for both the conventions to find the value of principal argument. For the first example, the value of the principal argument through this convention 1 is 315 degree and through convention 2 is minus 45 degree. Do you visualize any relationship between these two values of arguments? Yes, these two values of principal argument differ by only 2 pi. Now once again look at the value of the principal argument obtained for the example 2 in the convention 1. You will see that theta equal to 240 degrees, the value of principal argument over there. And in the second convention, the value of the principal argument for the same complex number is minus 120 degree. The value of the principal argument obtained through convention 1 is very old. This method is continuing from long time. But nowadays, the value of principal argument is obtained through the second convention. So you concentrate on the second convention only, in which the value of the principal argument is allowed to vary between minus pi to pi. Excluding minus pi means semi-open, semi-closed interval minus pi to pi, which is open at left, and there is not any difference in the concept and all. So don't confuse the two set of rules to finding the principal arguments. Follow the rule which is given in your textbook and what is followed in your college and schools and all. Now this argument of a complex number also possesses various peculiar properties. The argument of the conjugate of a complex number is equal to negative of the argument of that complex number. An argument of the product of two complex numbers z1 and z2 is equal to argument of z1 plus argument of z2 plus 2k pi. Similarly, argument of z1 by z2 equal to argument of z1 minus argument of z2 plus 2k pi. Argument of z to the power n equal to n into argument of z plus 2k pi, and argument of z by z bar equal to 2 into argument of z plus 2k pi. Here you must take care of one thing, that this 2k pi is added only to maintain the principal value of the argument, where k is allowed to take value 0, 1 and minus 1, so as the outcome comes out to be a principal argument and all. And if the value is already coming in the range of the principal argument, then there is no meaning of adding this 2k pi, means indirectly ultimately putting the value of k equal to 0 and vanishing this term. If argument of z1 by z2 is equal to theta, then argument of z2 by z1 is given as 2k pi minus theta. If the argument of z equal to 0 or pi, then the complex number z is purely real. Similarly, if the argument of a complex number z is pi by 2 or minus pi by 2, then complex number is purely imaginary. Now thank you for watching UKSing Maths. If you wish, you can like and subscribe UKSing Maths, the YouTube channel, to stay connected with us. You are free to comment on the content of the article and suggest any improvement if any. Your suggestions are always welcome and highly appreciated. Thanks once again.